How many sensors does a sport need? 4 papers, for different sports, all asking the same minimal sensor question. Each of these 4 papers reduces a full-body inertial sensor suit down to a small, field-deployable set for one specific sport skill, and validates that reduced set against a gold standard reference. Whether a minimal configuration validated for one skill transfers to another is a question none of them individually addresses, and is the thread this group follows across running, base running, jumping, and throwing. A single lower back sensor predicted most running gait metrics with high accuracy, but consistently missed left-right asymmetry until 2 ankle sensors were added. The test was steady-state treadmill running at 3 speeds, not sprinting, not outdoor terrain, so whether this specific 3-sensor recipe holds outside the lab is not established here. It sets up the question the rest of this group returns to: is there one minimal set that works across sports, or does every skill need its own? This paper offers a methodological template for interpreting footpod signals during baseball base running, contrasting straight-line sprint capacity against the curved path of an actual base path. Unlike the previous paper's 25 runner validation, this is presented as a case-based approach rather than a large sample study, so how reliably the interpretation generalizes across athletes is not yet demonstrated. Base running is also biomechanically distinct from straight running, curvilinear, with lean and cutting, so a lesson from linear gait may not transfer directly. A high sampling rate and a derivative-based takeoff landing algorithm gave this single lumbar sensor strong agreement with a force platform reference, across 119 jumps from 19 participants. A counter-movement jump is vertical and largely symmetric, a more constrained, repeatable task than base running's cutting or the rotational throw that follows. Whether the same single sensor approach degrades once the movement becomes asymmetric or rotational is exactly what the next paper tests. Hammer throw is rotational, multi-axis, and explosive, a harder case than the linear or vertical tasks in the first 3 papers. Reported agreement with professional motion capture suggests the minimal sensor approach can extend to this more complex movement class, not only to running and jumping. But throw count, fatigue effects, and skill level range are not detailed here to the same depth as the running study, so how the method holds up across a full training cycle remains open. Across all 4 papers, a minimal sensor configuration validates well within its own narrow task, but none has been tested against another sports protocol in the same study. Whether a single lumbar sensor generalizes across running, jumping, and throwing, or whether every sport-specific skill requires its own bespoke sensor count and placement, remains an open question, one that a single cross-sport validation study could resolve, but that none of these 4 attempt.